Okay, so we're beginning section 3.1, pairs of lines and angles. Essential question, what does it mean if two lines are parallel, intersecting, coincident, or skew? Identify lines and planes, identify parallel and perpendicular lines, and identify pairs of angles formed by transversals. So, quick little quote, God draws straight with crooked lines. Just some food for thought. Lines and planes, parallel and skew lines. Two lines are parallel lines when they do not intersect and they are coplanar. So N and M are parallel. They're on plane T. They do not intersect. And notice, this is important, see these arrows? That indicates that they are parallel. Lines M and N are parallel lines. And we write that, as you can see right here, M and N are parallel. Skew lines are two lines are skew when they do not intersect and are not coplanar. So for example, M and K, they are not on the same plane. M goes behind K and will never touch it. But because they are not on the same plane, they are not parallel. And then our last definition, parallel planes. Two planes are parallel when they do not intersect. So planes T and U are parallel. Notice how T is on top. It's like a card on top of another card U with space underneath. So they are parallel. They will never touch and they are on top of each other. Lines K and N are intersecting lines. So K and N intersect at this point right here. There is a plane that would contain them, but it's not shown in that picture. Example 1. Which lines or planes appear to fit the description? Lines parallel to CD and containing point A. Here's A. What line is parallel to CD? So it's on the same plane, but it does not touch it. Well, if we think of this as a box, the top of this box is like a plane. AB is parallel to CD and does not touch it. So the answer is line A, B. B states which lines are skew to CD and contain point A. So CD, skew means they're not on the same plane and they are not going to intersect. So there's several of those lines, but the only one that contains A is line AH. And you could also say HA. That's okay. You can say it backwards. C says which lines are perpendicular to CD. Here's CD. Perpendicular, if two lines intersect to form a right angle, they are perpendicular. Here's the right angle. What line touches CD at a right angle and contains A? That would be line AD or DA. And then part D says what plane is parallel to EFG containing point A? So EFG is the bottom of the box. That's the plane on the bottom. Parallel to that and containing A would be the top of the box. So what's the symbol for plane? Well, there isn't one. We just write out the word plane and then we have to pick 3 points. I picked A, B, and C. Parallel and perpendicular lines. Two distinct lines in the same plane are either parallel, like L and N. So right here we have L and N. They're parallel. See our red arrows? They're on the same plane and they do not intersect, or they intersect in a point like J and N. So look at line J and line N, they intersect right here at P. So we can say through a point, not on a line, there is infinitely many lines. So look at point P. I can draw J through P, or I can keep on drawing line after line after line, as many as I can fit. And I can just keep going all around that point. Then I could go through the point and start drawing lines in other planes and just continue on and on and on infinitely. So through a point, not on a line, there is infinitely many lines, but there is exactly one of these lines is parallel to the given line. So line N is the line through point P parallel to L. So if I told you, here's line L, I want you to draw a line through point P parallel to L, you would have to draw N. There is no other line that would make that work. And the same thing is true for perpendicular. Through a point, not on a line, there is infinitely many lines, but exactly one of these is perpendicular to the given line. So line K through point P is the line perpendicular to L. So if I drew L and I said, draw a line through point P perpendicular, you could only draw K. There's no other way to make that work. So from that, we have two postulates, the parallel postulate and the perpendicular postulate. The parallel postulate states exactly what we said before. If there is a line and a point not on the line, then there is exactly, so if there is a line and a point not on the line, there is exactly one line through the point parallel to the given line. So if I have L and I say, here's point P, draw a line through P parallel to L, you can only draw that red line. There's no other way to make it work. Same thing for perpendicular. If there is a line and a point not on the line, then there is exactly one line through that point perpendicular to the given line. So if I draw L and tell you through point P, draw a perpendicular line to L, you can only draw that red line. There's no other way to make it work with any other line. Example 2 says, the given line markings show how the roads in town are related to one another. A. Name a pair of parallel lines. Parallel lines are in the same plane and they never intersect. So right now, I can see these double arrows? That's telling me that line DM and EF are parallel. So I have my answer right there. A is line DM, or you could say MD, and line, let me actually say this, DM is parallel to line EF. What does B state? B says, name a pair of perpendicular lines. Here's my right angle, so I can say that DM is perpendicular to BM. So I can say for B that line DM is perpendicular to line BM. Let's pause for a second and remember our symbols. Two vertical lines mean parallel. An upside down T means perpendicular. Parallel to, perpendicular to. Let's answer C. Is FE parallel to AC? And the answer is no. Because FE is not parallel to AC. Number one, I could see that if I continued going on and on and on, in that direction, they would eventually touch. But the other reason is because we know that through a point, M, there is exactly one line. So through point M, because of the parallel postulate, there is exactly one parallel line to EF, and we already know that's DM. So the answer is no. A new definition, we have transversal. A transversal is a line that intersects two or more coplanar lines. The transversal is a line that intersects two or more coplanar lines at different points. I should probably have used different colors. Those are too similar. So a transversal, which is pink right here, is a line that intersects two or more coplanar lines in different points. So we have lots of definitions from that. We have numerous angles formed when a transversal cuts across lines. The first one is corresponding angles. And they are angles that are formed when a transversal crosses two lines and we have corresponding positions. So 2 and 6 are both to the right of the transversal T and above the two lines. And there's numerous other spots that would have corresponding angles, and we're going to see those in the future. The next one is alternate interior angles. The interior of the two lines is what I shaded in pink. It's in between the two lines. And the angles that are formed on the interior and alternate over the transversal, so they're on opposite sides of the transversal, are called alternate interior. Alternate exterior angles are on the outside of our two lines, and they're the angles that are formed when they alternate on either side of the transversal on the outside, opposite sides of the transversal. And the two consecutive angles are angles that are formed, they're consecutive interior, so they're on the inside of our two lines, and they're consecutive, which means they're on the same side of the transversal. So when they lie between the two lines and on the same side of the transversal, they are consecutive interior. So identify all angle pairs of the given type. So first, let's find our transversal. Our transversal is in purple. Transversal. Which are our corresponding angles? Corresponding angles are in the same position on either side of the line, same side of the transversal. So one set is angle 1 and angle 5. And angle 5. The next set, 2 and 6, are on the right side of the lines, top of the transversal. 3 and 7, bottom of the transversal, left of the two lines. 4 and 8, angle 4 and angle 8, bottom of transversal, right of the lines. Our next sets are alternate interior. So interior is anything in between these two lines. Alternate means they go across the transversal. So angles 2 and angle 7. And then our next set is 4 and 5. Angle 4 and angle 5. Alternate interior. Alternate exterior they're going to be on the outside of our lines, and they alternate on the transversal. So 1 and 8, they're on the outside of our lines, and they are on opposite sides of the transversal. And 3 and 6, angle 3 and angle 6 are the only other two. And then our last set, transversal, we have consecutive interior. We're looking in between our two lines. Consecutive means they're on the same side. So we have angle 2 and angle 5. Consecutive, same side of the transversal. In between, consecutive interior. Same side of the transversal. In between the lines, angle 4 and angle 7. Recap, lots of definitions. Parallel lines, skew lines, parallel planes. Identifying parallel and perpendicular lines. The parallel and perpendicular postulate. And then most importantly, the 4 different types of angles formed by transversals. These we're going to use in the future, and we need them for the next section. Please understand these 4 types of angles. That's all. Make sure you have your notes filled in and you have them ready for class. And I will see you at class.